Hello everyone, my name is Shridan Abdullah. I am from Egypt. First of all, I want to thank Emertxe Information Technology for providing us such internship program. We're gonna go through our final project video presentation for a washing machine. Our agenda, we're gonna talk about the overview and goals of internship and what we learned during the internship, and we're gonna talk about development process and tools. Also, we're gonna include the project requirements, design, implementation details, and conclusion. And finally, we're gonna show the demo video. First of all, we're gonna talk about overview and goals of internship in the project. The project encapsulates the efforts of the online embedded system internship, centering on the simulation of a washing machine through PIC16F877A. The goals of internship: we simulate washing machine functionality using PIC16F877A as a microcontroller. We gain hands-on learning experience. By engaging in this project, we gain practical experience in applying embedded systems concepts we learned here to simulate complex operations. This hands-on approach complements theoretical knowledge and fosters a deeper understanding of automation, control system, and embedded systems. We learned C as a programming language, and we go through embedded C, and we learned that embedded C is also a C programming but used for embedded systems applications. We used in embedded systems applications for its characteristics like efficiency, portability, and closing to hardware capabilities. We go through data types and operators, data types like integers, floating point numbers, characters, and custom data type. Also, we go through operators like arithmetic operators, relational operators, logical operators, bitwise and assignment operators, and also many operators like size of operator. We go through control flow like conditional statements like if else, if else if, else, and so, and also switch case. For looping constructs, we used for loop, while loop, and do while loop. For functions and pointers, we used function to make our code more modular, to use it easily with parameters and return values. Also, we used pointers to enable manipulation of memory addresses for direct hardware interaction. Also, we know embedded systems concepts. First of all, we talked about the definition of embedded systems. We know that it is specialized computing systems designed for performing dedicated function within larger systems or devices, like smartphones, automotive systems, medical device, and many more. Its characteristics, like real-time operation, we know that embedded systems often need to respond to external stimuli or events in real time. Also, we know that there is resource constraints. It's very limited to power, memory, energy, and so. We know that it's a deterministic behavior, so the behavior should be predictable and consistent. Also, we know the components of any embedded system. First of all, it's microcontroller or microprocessor, which is the brain of the embedded system and responsible for processing, executing tasks. Also, we go through memories and memories type like volatile and non-volatile, which store program instructions and data. Also, we go through input-output interfaces to enable communication with external devices and users, and go through power supply, sensors, and actuators to collect data from the environment and initiate actions respectively. For the development process, we know in the project, like we use the process in the project like requirements analysis and then design, and then we go through the implementation and we test what we implement. And also as a development process, we go through the deployment and maintenance. The hardware tools we use PIC16F877A as our microcontroller. It's very popular microcontroller and widely used in embedded systems. Its ports, like it has multiple I/O ports, including port A, port B, port C, port D, and port E. Ports can be configured as inputs or outputs for interfacing with external devices. Also, we go through timers. The microcontroller includes multiple timers, counters, for various timing and counting applications, like timer 0, which is 8-bit timer, and timer 1, timer 2 was 16-bit timers with prescaler and postscaler. Also, we go through interrupts concepts. We know that interrupts allow the microcontroller to respond to external events asynchronously. Also, we know that the type of interrupts was external interrupts and internal interrupts. And we know that interrupt service routines, which also called ISRs, handle interrupt events and can perform time-critical tasks. And for the interfacing with the microcontroller, we used character LCD, also known as CLCD. We interface CLCD with PIC16F877A to enable displaying status, data, and messages in our applications. We connect data pins, control pins like RS, RW, and enable, and we configure the CLCD for 4-bit or 8-bit mode, and we set display options and clear the display also. Also, we send data. Sending data was like send commands and characters to display text and control the display behavior. Also, for interfacing with PIC, we used keypad to allow users to input information and interact with the system. The hardware connection was connect keypad rows and columns to microcontroller pins, and with scanning technique to know which key is pressed. And for the software tools we use PixMLab for the simulation and Map MP Lab X IDE to writing the code and XC8 compiler. The internship process, we go through C programming and embedded C in the first, and then microcontroller and embedded systems concepts. Then we go through applications tools, and we start to apply these applications in our project, and then we execute the final project using what we have learned. Our problem statement for the project, the problem at hand is to develop a simulation for washing machine using PixMLab. This simulation aims to emulate real-world washing machine operations, including various cycles, control mechanism, and parameter adjustment.
Hello, my name is Ammar Barrous. I'm a mechatronics engineer from Jordan. Today I am going to present the system requirement and the functionality of the washing machine. In this slide, we see components of the system. We have four push buttons to control the machine, a display for user interfacing and monitoring, and the fan as a motor. Also the buzzer for make sound. We press switch 5 to power on the system. As soon as the switch is pressed, the screen changes to powering animation. We can see the photo in the slide, how the animation will be. In this screen, we select the washing program, and we have 12 programs. Pressing switch 4 will change between them, and long press will make selection. After choosing the washing program, we go to select the water level. We have 5 choices for water level. Same process as before. Switch 4 will change between them, and long press will submit the choice. Now we are ready to start washing by pressing switch 5, or cancelling the process and back to the start screen by pressing switch 6. When the washing cycle starts, the status screen will display, and the status screen will display the estimated time. Then it will proceed to wash and rinse and spin the clothes. the clothes. While washing is in progress, if the door switch is pressed, the washing process will stop. Also, an alarm screen will appear and the buzzer will turn on. When the countdown timer reaches 0, the full screen is displayed and the buzzer is activated. The buzzer will be activated for a period of time before resetting the system. As a conclusion, the washing machine simulation using PIC16Lab provided an effective hands-on learning experience, complementing theoretical knowledge in embedded systems. It laid a strong foundation for further exploration in automation and control systems. We will see a demo for the project. We can see now how we change between the modes by pressing switch 4, and after long press it's changed to the water level. Now we open the door and the buzzer is working. Here we press the pause button. Test it again. System done. Thank you for your time.